This is our fourth video for the Probability and Statistics unit, and we are introing statistics in this video. You may have to pause it and input some things in your calculator, so have your calculator beside you as you are working on this. I will be using my TI-84. So if you have an Inspire, you might need to come see me to input some of this data. I think you can figure it out pretty easily. But you may have to pause the video so you can get some of this data inputted. So in statistics, we are trying to make conclusions from data sets. So what kind of data could we gather to determine if our class was healthy? So we might do some comparisons about height and weight, eating habits, exercise, your heart rate, your blood pressure, medical history. I'm sure you guys can think of some other data we could collect. If we were to collect this data, maybe we collect your all's pulse rate over 60 seconds. What statistics could we use in analyzing the results? We could calculate the mean, the average, the median, it's the number that's in the middle of our data set, and the mode, which is the one that occurs the most often. You have found all of those before. We're going to focus on looking at the mean today, which is a measure of center, and standard deviation, which is a measure of spread. You probably have used other measures of spread before, one being the range of your data set, the max minus the min. The other involved box and whisker, was called the IQR, or interquartile range, and you may have been exposed to those in previous math classes. So what is a mean? The mean is the average of all data. You know how to find that. Some notation that we use. If our data is from a sample, we use X bar. If our data is from an entire population, we use mu. Most often we can't take data from an entire population. It takes too long, it's expensive. So most times when you are reporting a mean, it is a sample mean. What is standard deviation? It is the average distance from the mean. The average distance from the mean. It is a measure of spread. If our data is from a sample, we use a lowercase s. If the data is from the entire population, we use the Greek letter sigma. Now this is a lowercase Greek letter sigma. You worked with a capital Greek letter symbol, sigma, when you were doing summation notation. So we have the following situation. We have information about how much money is withdrawn from an ATM, and we sampled 32 withdrawals. You have this on your paper. I'm going to go straight to my calculator, and I have already inputted this into my calculator. So I'm just going to follow the instructions like you have it. If you want to input this data in your calculator, go to Stat and Edit. I have already input all of the data into L1. You might want to pause the video and input it into L1 so you can follow along. One thing I do like about my calculator, it is if I am on the last data entry, it tells me it's 32. It's the 32nd entry. If you go back and read the problem, it tells us that we should have 32 entries. I do that as a way to check myself. Now, your calculator will actually find the mean and the standard deviation for you. Hit Stat, go over to Calculate, and you want to choose the first one variable statistics. Just hit Enter. Now my calculator has a newer operating system. Most of yours do as well. So notice it says list L1. That's what it should say. If it doesn't, hit second and the number 1, and it will change that to L1. Do not put anything under frequency list. Hit calculate. If you have one of the older calculators, you shouldn't have to do anything. Its default is L1. So after some tabulating, we see X bar. That's the mean. Notice it's the sample mean. We see a sample standard deviation, that is S. That's what we will be using. 32 withdrawals is not the population of withdrawals from the ATM machine. Here is our population standard deviation. So S is our sample standard deviation. Sigma is our population standard deviation. Notice they're a little different. N is the number of data entries. We have our minimum data entry, our median data entry, and our max data entry. So we have all the information that we need. So if you're following along in your notes, it asks you for the mean. We are talking about money, so I'm going to use units. It's $34.69. And the standard deviation, again, I'm using a sample, so I will use S. The standard deviation is $20.98. And standard deviation, again, is how the average distance your data is from the mean. Now, it wants you to graph. Again, you have the instructions. I'm going to do it on my calculator at the same time. I'm going to go to second, stat plot. I'm working with data, so I'm going to turn my stat plot on. The default is regression. You've done this before. However, if you scroll over, you will see a histogram. That's what you want to select. Hit zoom, statistics. And here's your histogram. If you hit trace on your calculator, your histogram will tell you how many of your entries are contained in this bar. It tells us that this goes from 10 into 21.667. Really, 10 to 20 is contained in that bar. This one contains 8. It contains everything from $21 to $33, $33 not being included. And you can scroll and continuing to look at all those histograms. Now, I'm going to skip around a little bit and talk about the shape of this graph. Where is most of our data? Most of our data is on the left-hand side of this graph. This is actually called skewed right. The tail is on the right. If I were to draw a curve over this data set, the tail would be on the right-hand side. So this is called a shape of skewed right. Now, you have a couple of other practice problems here. I'm going to show you the answers. You can do it in your calculator. Go back and read the directions if you need help. So the first one about the number of multiple choice questions. Correct. Here's the mean and the standard deviation. I have sketched the histogram. It did ask about a couple of questions over on the side. It said, what's the width of each bar? If you hit trace, your calculator will give you the low value of the bar and the upper value of the bar. Subtract those and you get your width. That's called the class width. Then, your second example. Again, you can pause the video, make sure you know what's going on, input this in your calculator. We can see the mean, the standard deviation, the histogram, and the class width. Now let's go back for just a second and talk about what the shapes of these graphs would be. So if I'm looking at my example 2 histogram and I were to draw a curve on it, this has a tail on the left-hand side. This is called skewed left, meaning most of the data is on the right-hand side of your graph. Example 3. If I were to draw a curve, what shape would this be? This is probably one you've had a lot of experience with. This is called a bell curve, or a normal curve. Standardized test scores are graded on a normal curve. IQ is a normal curve. Height of 9th grade boys would be a normal curve. That occurs quite frequently. So the next page just has some vocabulary, and so I have filled this in for you. So when we talk about shape, data can be symmetric. If you fold the histogram in half, the two sides would meet each other. Now, if you look on the bottom, we can see some examples of some different shapes. We'll talk about that in a moment. We can have skewed right. That means the tail is to the right. Most of the data would be on the left-hand side. We have seen an example of that. Skewed left. The tail is on the left. When we talk about values to help us evaluate or interpret our data, we want to talk about the center. What would the average be? We want to talk about the spread, how spread out is our data. And if we have any outliers, we could have outliers in our data. So here are some examples: symmetric, skewed left, or skewed right, the tail is on the right, skewed left. We can have graphs that are unimodal. If we were to draw a curve, it has one high point. Bimodal. Notice that when we're talking bimodal, we're not talking about what's the highest bar. We almost see like there's two clusters of data set. And multimodal, we have multiple groups, if I were to draw curves here, over our data set. When we talk about center, we have two measures of center: mean and median. When we are summarizing data, we use the mean when the data has no outliers. Because what would an outlier do to our data set? If we're measuring the height of our class and we have someone in our class who's 7 feet 8 inches, they would skew our data set. They would be an outlier and would pull the mean up. So when we have an outlier such as that, we would report the median. It would be the best measure of center. Again, that's the number in the middle. As far as measures of spread, we can talk about two types of spread, one being standard deviation. Now remember, standard deviation is the average distance from the mean. So if we have somebody that walks in our room that's 7 feet 8 inches, they are going to make the standard deviation be larger. We probably wouldn't want to use standard deviation for our spread because our data is skewed by that really, really tall person. So we would use range. And range is simply the maximum data value minus the min data value. Okay? So again, we're just throwing some vocab words out there for you to use in interpreting data sets. And so that's the end of the notes for today. Again, practice those calculator skills. And if you need to pause the video or go back, you certainly can.